fellow ag nerds, thank you so much for joining me for this episode of the Future of Agriculture podcast. My name is Tim Hamrich, and if you're curious about where innovative ideas meet practical realities in food production, you have found the right show. Special shout out today to Loki Aguilera-Kiefert, who recently decided to support this show financially and join the FoA community. You can join Loki and others over at patreon.com/agriculture. Thank you so much to all of you who support these efforts. We've got a really great show for you today. As many of you probably know, Microsoft has had a real presence in ag tech in recent years, both with its FarmBeats project and, of course, with its Azure cloud computing service. The FarmBeats effort can be traced back to 2015 when today's guest, Ranveer Chandra, wrote a memo which led to him starting and running that FarmBeats project. FarmBeats, for those of you who may not know, provides a way to collect on-farm data and track that data using cloud computing models. It's not a product that farmers go out and buy, but it's a platform that ag tech companies can build upon. In fact, you've heard from previous guests of the show who are customers of Microsoft to power their own technologies. Ranveer is the chief scientist of Microsoft Azure Global and partner researcher at Microsoft Research. He started the FarmBeats project in 2015 and has been leading it ever since. He's also leading the battery research project at Microsoft and the White Space Networking project, which provides rural connectivity using unused TV channels. That's where the TV white spaces comes in. He was invited by the USDA to present his work on FarmBeats, and his work was featured by Bill Gates in GatesNotes and was selected by Satya Nadella as one of the 10 projects that inspired him most in 2017. Both FarmBeats and that TV Whitespaces project started with memos. And as you're going to hear, Ranveer wrote his 2020 memo on sustainability. So we're also going to get into the discussion about sustainability data and Microsoft's big open source carbon purchase from a few months ago. So anyway, this is a great discussion about the future of data-driven agriculture. Make sure you stick around to the end to hear ideas like using a cell phone to measure soil carbon. But first, Ranveer's going to take us to the genesis of what is now FarmBeats.
FarmBeats started as a personal interest project. So I'm a researcher. I'm not an agriculture scientist. I'm a computer scientist. I did my PhD in computer science from Cornell University. I joined Microsoft in 2005. And I've been working on various computer science technologies, inventing new networking protocols, building new artificial intelligence algorithms, writing research papers, shipping it in products. That's what I was doing. Nothing to do with agriculture. One of the projects I had done was TV Whitespaces, which was on providing connectivity to rural areas using unused TV channels. And that was one of the projects, and I started going to farms, looking at those were some of the regions that I could get connected. And the other thing that had happened that has influenced my career and all the projects I work on is my upbringing. I grew up in India, and while growing up in India, I spent a lot of time in my grandparents' farm. This is in a state called Bihar in North India. Every summer and winter vacation, as it happens with people in India, you spend it with your grandparents. So I would go to my grandparents' farm, me, my brothers and sisters, and we would spend time there. Back then, I did not like anything to do with agriculture. These farms, they did not have any electricity. They did not have any toilets. I used to spend, say, 3-4 months every year in these farms. Even though I did not like my time in these farms, it did expose me to a lot of primitive forms of agriculture, like bullock-driven tractors, hand-based seeding, and a lot of poverty. And that has stuck with me ever since I came to the US when I was 18 years old. This picture of poverty is stuck in my mind. And through all the projects that I do, I try to create an impact on the people in these emerging markets, people who live in these villages, in these small farms. And that is one of the reasons I started working on FarmBeats as well, where once I started developing a lot of tools, one of the ideas was that if we bring the benefits of data and AI to these farmers worldwide, they would start benefiting in their practices. They could start being more profitable. They could grow more food. They could use sustainable agricultural practices. So that was the genesis, that there is this gap, there is a need for more intelligence in farming. And there is a gap in this intelligence not being affordable for most farmers worldwide because the technologies didn't exist. So that's what led to the start of this project back in 2014 is when I wrote the first memo that this is what we should be building at Microsoft.
Okay, and so that was going to be my next question. So is that how it works in Microsoft, at least in your role? If you stumbled upon something that you viewed as an opportunity, you could write a memo and then if kind of given permission, pursue it. Is that right?
Yeah, so in different teams within Microsoft, so Microsoft has people who build products, there's engineers, Microsoft has people who are in the sales business org. I was part of Microsoft Research back then. Even now, I'm back in Microsoft Research, where Microsoft Research is a few hundred PhDs working in various areas of computer science and electrical engineering. And some of the work there is curiosity driven as well. In addition to some of the work is more advanced. We impact products. We also think of things that are much ahead in the future. So at Microsoft Research, when it was established, it was set with three goals. The goal one was to advance the state of the art in computer science. The second was to make sure that any of the research that we do ships as part of Microsoft products. And the third was, the way Bill Gates had put it back then, was to make sure Microsoft has a future. And towards that goal is every 5 years I start this longer term project, which might or might not work out, but it is something which Microsoft might not be doing right now, but should be doing in the future. So like in 2005, one of the projects I had started was on TV white spaces. I started working on that. In 2010, I started working on battery research. And 2015 is when I started FarmBeats. 2020 is past. One of the things I started is working more on sustainability. But that's one of the ways in which Microsoft Research operates, is where we think of make these ambitious bets on projects and try to make them happen.
Okay. And I do want to get back to sustainability, but let's stick on FarmBeats for now, and then we'll try to get through 5 years in about 20 minutes and then move on to the next 5 years. But going back to writing that memo, was part of that memo trying to convince Microsoft that there was a market here, that the people wanted to buy this stuff? And if so, kind of gets to my question, could you picture your grandparents buying, something if this technology sort of existed?
Yeah, part of the vision back then was Microsoft did not do agriculture back then. And for me, it was more about showing the opportunity of what you could do if we brought all the Microsoft assets, did some new research on how it could transform agriculture, how it could transform the lives of farmers. And yeah, my grandparents and smallholder farmers were also front and center in my mind as to potential customers of what we build. And at Microsoft, we are not an agriculture company. We don't build something directly for growers. Our go-to market is always through a partner, through someone else, an agriculture company who would build the solutions on top and take it to the growers. The platform was what was FarmBeats. What could this platform look like? So yes, of course, it was about this opportunity showing what could be the future of agriculture, of food, if we were to make agriculture more data-driven. So data-driven agriculture was the concept we coined then, and we started pushing more on that. And at Microsoft, we have a lot of this growth mindset where it is about, if you have an idea, we can take it all the way out to our CEO, who in this case, Satya read about FarmBeats. He talked to the growers. He wrote about it on LinkedIn. Bill Gates blogged about it. So we got a lot of visibility from our senior management, which helped us then transition it from a research concept to a real product.
And going back to that time, when you wrote the memo, 2015, so it's still early days of a lot of the digital ag tech products that have come. But, already Monsanto had bought Climate. There's already things going on. So as you looked out, where did you see a clear gap in that landscape? And do you feel like, now in reflection, that you all have been able to accomplish what you set out to fill that gap?
Yeah, but that's a good question. And back then, Monsanto had bought Climate Corp. They were among the first big data-driven agriculture acquisitions. But still, a lot of use of data and AI was missing from farmers worldwide. And there are a few key reasons for that. One is the cost of these digital agriculture solutions was a big barrier then, was a huge barrier then, has become lesser of a barrier now. Because these solutions are expensive. There is very little internet in the middle of the farm, and it becomes hard to get data. If you're not getting good data from the farm, you're not really being able to drive your artificial intelligence models to start making these predictions. So the number one barrier was cost, and driven in large part due to lack of connectivity, which is still an issue, but it's people have realized it more. So that was one of the biggest blockers. The other blocker was the use of AI. And Climate Corp started doing it, but they were looking at data that's coming in from remote sensing data from satellites, which have coarse-grained, and they're limited in giving you the actual ground truth of what's happening. So that was the other barrier. How could you bring in data from the middle of the farm and combine it with data that you get from remote sensing, say from satellites, to start adding new insights? And so those were some of the key blockers that, if you look back at 2014, 2015, only some of the very elite farmers could be thinking about digital agriculture. Now, when we talk to through some of the partnerships that we've created, working with partners and bringing our own platform to these partners, we believe we are democratizing data-driven agriculture to farmers worldwide. We're starting with some of the developed world, but if you look at some of the most recent announcements in Indonesia and India, where we partnered with the government, with partners who are in the local region, we are looking to democratize data-driven agriculture, bring it to farmers worldwide, bring the benefits of data, bring the benefits of AI to every farmer worldwide. And to be completely clear, Tim, we are still scratching the surface of data-driven agriculture. Even now, we don't yet understand very well what's happening in every part of the soil, every part of the farm, what's happening above and below the soil. We have no visibility into that. We will get more visibility into it once we start getting the data, once we start bringing genomics into the picture. So I'm really excited about what's in the future, but at least where we are now compared to 2015, I think we've taken big steps, but a lot more is going to come.
Yeah. I don't think anyone could argue against the fact that from 2015 to today, yourselves and others have made data much more accessible to most farmers. And I'm speaking in mostly a North America context because that's what I'm most familiar with, but certainly in other places as well. So if you could go back, to that memo you wrote in 2015, what that you thought would be true by now turned out to not be true, if anything?
That's a great question. I really wanted more broadband in the middle of a farm. I really think that is still a blocker to the adoption of more data-driven agriculture. What has changed is back then I saw the gap, wrote it in the memo. We've shown public demos to regulators at the USDA, at the FCC about what broadband in the farm can enable. The good thing that's happened is that the discussions have started. The FCC set up a Precision Ag task force across the FCC and USDA. They ruled out rural broadband initiatives. The TV whitespace regulations have been more relaxed. So there has been action, which is great. But I think the penetration of broadband still has long ways to go to get to the middle of the farm. I think right now, what we are trying to bridge is bring broadband to the farmer's house. The next step is to bring it to the middle of the farm. And once we do that, I think data-driven agriculture is going to explode. Once you get data from the middle of the farm and to a farmer who's in the middle of the farm, you'll see all sorts of data-driven agriculture solutions explode. The kind of thing that I wrote in the memo then about a farmer using data in the middle of a farm to drive decisions, machines using data to take decisions. We need connectivity to make that happen. So that's one of the things which I think the good thing is that there have been more discussions, more actions, more realization that this is needed. What hasn't turned out to be true yet is we still see a big gap. There's still more majority of the farmlands still don't have broadband connectivity.
And through FarmBeats, do you supply any hardware at all, or is all the hardware from the agtech partners and the agribusiness partners that you work with?
It's all through partners. So right now, even when we build solutions, we then license it out to our partners who then build the solutions. And it's a partner solution. Like one of the things we did was we created a TV whitespaces IoT radio. So TV whitespaces, it's a way to use unused TV channels to send and receive data. One of the things that we've been developing for the last 4 years was instead of just sending broadband over unused TV channels, can we send narrowband data? So you can think of really long range, like 15, 20 miles of connectivity using a very low power, long range solution. Your sensors, your tractors can communicate all the way to your home using these solutions. So we built it. The FCC recently passed regulations making that operation of those things legal. And now we license that tech out to a partner who's now commercializing it. But we are not building hardware ourselves. Even the eventual agtech solutions is something that we are not building. Our partners are building that on top of the FarmBeats platform.
Gotcha. Yeah. And if this was, instead of being a podcast interview, if this was like a strategy session here, the strategy is then to basically have the digital infrastructure for which ag tech providers build on top of and then provide it to farmers, right? I mean, long term, that's how Microsoft benefits from their commitment to agriculture.
Exactly. So Microsoft, one of the things that we are doing for multiple industries is we are enabling the digital transformation of these industries by building the cloud platform that enables that digital transformation. And for agriculture, it's the same. We are building this cloud platform that can bring together data from different data streams. Like, for example, for agriculture, from satellite partners, from weather partners, from sensor partners, tractor partners, drone partners. We bring all of that to this platform in the cloud. And then we enable the ag tech companies to build their solutions on top. Like, for example, what we're doing in the partnership with Land O'Lakes. So Land O'Lakes is building this digital agriculture solutions on top of Azure FarmBeats and taking it to the growers.
Okay, great. What is the data arrangement on that? I mean, with all the data going through you, if somebody was concerned about, okay, well, is Microsoft just getting all this ag data and then going to benefit from it, at our expense type of thing? What do you say to that?
No, so we don't have visibility to the data. It's a contract between the ag tech company or the data provider and the grower. We don't have any visibility into that data. So that's one. The other thing we are doing, though, is we realize that there has to be some sort of data governance. So the kind of things we are still building on is a good data sharing platform. How do you make sure that data can be shared in a secure, privacy preserving way? How do you make sure that there is ethics behind AI? That's how you use AI. You want this artificial intelligence to not have a bias on the data, to make sure that it's explainable, to make sure that if an artificial intelligence algorithm says that there is a certain result, you can see why it said what it said. So being able to do all of that are things that we are building, but we don't have raw access to the data. That's something which we believe is a contract between the the ag tech company, the data provider, and the grower.
Okay, great. No, I appreciate you clarifying that. I know one thing you're a big advocate for is some sort of like a dynamic soil map. So you mentioned earlier, not only what's going on above the soil, but also below, and also not just the physical properties, but the biological properties as well. Can you talk about what a dynamic soil map might look like and what are the barriers to getting there?
Yeah, and this is where the soil has so many microbes. It's got physical, biological, and the chemical properties of soil, which affect everything around us. It's part of our ecosystem that we need to really care about. It affects agriculture, it affects the way plants grow, it affects everything from the watersheds to things like putting more carbon back in soil, has a role to play in climate change. It affects everything around us. So it's hugely important when we think about soils to keep the soils healthy. We need the soils to be rich and healthy, and we all have a responsibility to make that happen. And when we talk about that, as all of us, all the citizens of this planet, are custodians of soil, we all need to first understand what is the soil current, what does it look like, what's the health of soil, is it rich, is it poor, looking at all dimensions, the physical, chemical, and the biological properties of soil, because it's going to affect everything around us. Our goal is to build such a dynamic map. That is, you want to be able to say at any point in the world, what are the physical, biological, and chemical properties of soil at that location, be it a farm, be it a forest, be it a watershed, anywhere you go. Now, this is the problem. The thing is, right now, the state of the art is we kind of have very coarse-grained measurements. Like, for example, a farmer who wants to get a soil sample for the farm, they're going to collect these soil samples from multiple parts, mix it up, and you're getting one representation for multiple acres of the farm, which is probably not right. Even we know for soil carbon, we know for soil moisture, that these things vary in different parts of the farm. Even if you go from row to row, your numbers might change. But there is no good way to accurately measure it. So the state of the art is we have some maps, like, for example, what the FAO has done, and they've done a commendable job. And like, for example, what USDA is doing with NRCS and others with Sergo and these kind of maps. But these are very coarse-grained maps. So that's the state of the art. The other thing that researchers do is they have these long-term research sites. These are these few carefully selected sites where we collect these soil measurements over, say, tens of years, and we are trying to measure how things change. But that's only giving you this temporary resolution at that particular location. We're not getting anything what's happening around it. So that is the state of the art. So there is a big challenge of, okay, how do you make the soil map more dynamic? One of the biggest issues, one of the reasons why we don't have a dynamic map is the cost of sensing. That is, how do you build a dynamic map? How do you go and start taking a lot of these measurements? How do you take these measurements across all these biological, physical, and chemical properties over time for soil all over the world? So that's why at the National Academies, I was part of a recent panel which was organizing a workshop where we got all the experts from around the world to weigh in to say, what is the state of the art? How do we really address this problem around data? How do we dynamically bring the data in? And the solution here, I think this is mostly some of the early intuition, is not looking at a single source of data, but looking at multiple sources of data and using artificial intelligence and the advances in AI to merge these different data streams, to start adding the intelligence to know what's happening in different parts of the world with soil and to build this map in a more dynamic way. But this is an open problem. We need to bring down the cost of sensing. There's some work we are doing on that. We need to merge all of these different data streams using AI. There too, we need the world experts to come together, and we need good models, good physical, biological, and chemistry models to understand how do these soil properties change. But this is a big gap. This is an important problem. It's good that the world is having this discussion that we need healthy soils for a healthy planet, for a healthy food system, for healthy people.
And we've talked about precision agriculture, and the nice thing about, FarmBeats and what you're enabling there is that it not only is better for the environment because we're using just what we need where, but it's also better economically. And so then when you turn it to soil, that argument may or may not apply depending on the context. Doing what's best for the soil is probably the best long-term economically, but short-term it may not be. So how do you think about that problem?
Yeah. Which is true, and it goes back to some of the carbon discussions that's happening around us as well. That is, we need to put more carbon back into soil. We need to reduce our emissions. We need to sequester carbon. And one of the ways in which you could sequester carbon in soil, or you could improve the richness of soil, is by using the right agricultural practices, these regenerative agricultural practices, such as no-till or reduced-till, cover cropping, nutrient management, and such. But as you rightly pointed out, these approaches might, in the short term, they might not be economically the right thing to do. But in the longer term, we know what the benefits are. And completely agreed with that this is one of the things where there are going to be certain decisions that won't be economically the best decision to make in the short term. And that is one of the challenges we face right now, more so in the developing world than the developed world. If you look at the emerging markets, farmers there, they've taken big loans. They have to pay back the loans in a certain period of time. They don't have the capability, the buffer to take the risk, to take a hit on the revenue in the short term, to get it up in the longer term. They have to pay back the loan. They take these decisions, and that we've seen through decades of farming in different parts. For example, in India, that the soil has become extremely poor. If you look at the nitrogen use efficiency there, it's really, really low compared to what's here. And we need a way to address that. We need a way to bridge that gap, to enable farmers to take the risk, to do the right thing that's good for the planet, is good for the farm in the longer term. We need the right policies around it. It's a policy problem. We need to work with the regulators. We need to incentivize growers to be taking these big longer term decisions by either paying them or by giving them credit for using the right agricultural practices, or through some crop insurance programs or through government subsidies. We need to empower farmers to take these longer term decisions. That's one thing. And the second problem here is a technical problem. I think as technologists, we need to come up with the right tools to bring more visibility to the farmers about what they should be doing in the farm. The farmers need to know, based on certain decisions they take in the farm, how might it impact their yield? How will it impact their revenue? This kind of what-if analysis needs a good simulation platform, needs a good AI to do this kind of what-if analysis, bring in the different parameters in the simulator. Imagine a tool where a farmer can go and say, this is what I'm doing. What if I did this, this, and this? What's going to happen in the future? What if I practiced reduced till? What if I till this part of the farm but not this part of the farm? And we need those kind of technology tools to enable farmers to take the right decision. So I think it's both a technology and a policy issue, which we need to address to make sure that the growers or any stakeholder in soil takes the right decision to make sure that we maintain healthy soils.
Yeah, I hadn't really thought about that simulator idea before. That's really cool. I mean, do you know of anything like that that's being developed out there?
In research, we are exploring something like that, where you can start doing what-if analysis. We built a 3D simulator of a farm. We integrated with process-based models. There's a model called AppSim. We are trying to make those models even better. But there are some tools out there which we're trying to bring together, run it in the cloud, run it at scale, so it becomes really easy for a grower to use. This is not available right now, but we are working on it in research, working with a few growers, select growers, trying to see how they would use it.
Well, on pretty much every podcast, I'm sure there's been some sort of episode about carbon markets, about carbon trading. I mean, it's kind of what everybody's talking about right now. Microsoft is one of the few companies I know of that has actually, completed a large sort of carbon purchase from agricultural providers. Could you maybe talk about that and maybe your perspective post-transaction?
Yeah, so as you know, that Microsoft made a big climate commitment last year around climate change, where we said that by 2030, we are going to be carbon negative. That's we're going to be putting back more carbon back in soil than the amount we generate. And by 2050, we are going to remove all the emissions that we've ever generated since the time Microsoft was founded, which is a huge commitment if you think of it. And the way we get to, say, even the 2030 commitment, part of it is by reducing our own emissions. Our data center is starting to use renewable energy from our Xbox, from our supply chain. We'll be working on reducing our emissions. But that's not going to be enough. We have to make sure that we are able to work with our partners to put carbon back in soil. And towards that, we created a one-of-its-kind RFP last year, where we requested people who are willing to put back carbon, who are willing to sell carbon credits, to apply to the RFP. And we received a lot of submissions, out of which we picked several, so some in forestry, but some of them are quite different. We know that existing techniques of putting carbon back in soil are not enough. We need to support innovation. We need to support new ways of putting carbon back in soil. And towards that, we are supporting a few innovative solutions, like 2 in soil carbon, like with Land O'Lakes, we are purchasing from them. Similarly, we are also purchasing carbon from Climacell, which is about direct air capture. Now, these are still in the science realm. They are still very expensive if you think of how you put carbon back in soil or back from the atmosphere, either through direct capture or through right agricultural practices. There are a lot of open questions, but we believe we need to make the right investments in the more promising technologies out there if we have to meet this eventual goal of being carbon negative by 2030 and helping the world get to the 2030 and 2050 goals regarding climate change.
Okay. And so in your case, it sounds like then it was a combination of obviously helping to reduce your footprint through these offsets, but also supporting early innovations that might lead somewhere as well.
Exactly. That's what, and in particular for soil carbon, which I'm sure many of the people who are listening to this podcast would be interested in. With soil carbon, we do believe there is promise. That is something which plants by default, that's what they do. They take carbon dioxide and send out oxygen, and they send it to the roots as well. And so if you're practicing the right agricultural solutions, right agricultural farming practices, you're putting more carbon back in soil. People know that's the case. There are questions around permanence and so on. But for soil health, it's absolutely the right thing to do. So we know that it's the right thing to do for the planet is to use the right agricultural practices. Now, once you start building a market around it, is when the bigger questions arise. The bigger questions around, if you're bringing a market, you need to accurately quantify how much carbon is put in soil. Accurately quantifying it is a big challenge because the thing we were discussing before, even within the same farm, the amount of carbon varies from row to row. Within a few meters, you might see different values. So just to go and measure the amount of carbon is expensive. If you don't measure, your results are inaccurate. The key question then is, how do you, in an economically feasible way, come up with a reasonably accurately estimate the amount of carbon that's sequestered in soil that can enable such a market? That is, if you're thinking of carbon at $15 per metric ton, then you need to be able to quantify the amount of carbon that's sequestered in soil at a low cost. So that's a problem where at Microsoft too, we are looking at solutions that can help address it. We are working with partners. Again, as was the case with FarmBeats, even with carbon, we are building some tools around it. We are looking at how do you very affordably estimate the amount of carbon in soil. So there are some research projects that we are doing. There's some early incubation work we are doing around this to enable the existing agtech companies, the players in the space, to estimate the carbon at a low price. But that's the hard problem that we are all after.
Interesting. Well, let me bounce a theory off of you here is that what is going to facilitate more farmers being data-driven maybe won't be the agronomic decision-making, but maybe will be the sustainability metrics that their buyers wanting to incentivize them to produce. And then that kind of maybe helps be the catalyst for more data-driven decision-making. What do you think about that?
This is something we talked about healthy soils and having the right policy. And having the right policy and markets would require growers to document the data. Manually documenting the data will always have concerns around it. So how do you enable the right capture of data around soil measurements, data around farm management practices? All of this data needs to be captured and stored in a secure way. And that's where I think data-driven agriculture has a key role to play. So to answer your question, earlier we were thinking about data-driven agriculture as a facilitator for precision agriculture. Maybe it'll be a facilitator for sustainable agriculture, for doing the right operations in the farm. Because again, for precision agriculture, they would grow more food, grow better food. With sustainable agriculture, they would probably be paid more while maintaining a good planet. So it could be either of these, but you might be right. That is, if the right policies are in place, then sustainable agriculture might lead to increased adoption of digital agriculture, of data-driven agriculture. And that would be great for all of us. That would be great for the planet.
I'm getting to the point where I hear about a new carbon market or carbon platform like every week, and it just seems to kind of lack anything new to bring to the table. You know, do we need all these new marketplaces? What do we really need in addition to data infrastructure, which you've already talked about? You all are developing some innovative products in that realm. What else do we need to actually make this be something where a farmer can consider, hey, if I do X practice, I might earn X amount of revenue?
I think that's where, like the what if analysis tool I mentioned, the simulation tool, I think that would be new. I haven't seen anyone build it, but that kind of a tool would be great. I think one of the other things we need more innovation on is low cost estimates of soil carbon. We need people to innovate on new ways to estimate soil carbon at a really low cost, really democratizing it. And we are working on some of those at Microsoft. Like this was at the National Academies last year, just before the lockdown. I was giving the keynote at National Academies event, and I was talking about FarmBeats and the latest that we are doing in digital agriculture. And one of the tools I talked about was how you could potentially use Wi-Fi on your phone to measure soil moisture and soil EC, or soil electrical conductivity. The reason for doing that was, these sensors are very expensive. The soil moisture sensors or soil EC sensors cost hundreds of dollars, if not more. And most farmers, especially smallholder farmers, if you look at in India, they're not going to spend a few $100s buying a sensor in the farm. That's just way out of reach for them. But many of them have a smartphone, even if it is an inexpensive phone. If they have a smartphone, it has a Wi-Fi chipset in it. If it has a Wi-Fi chipset in it, the key thing we built was a way to measure the time of flight of Wi-Fi. The insight was that the time of flight of Wi-Fi depends on the permittivity of the material. So if your soil is moist, it will take longer to transmit the same distance than if the soil is dry. If you could measure that, then anyone with a phone can go close to soil and start measuring soil moisture and soil EC. So we built a very first prototype around it. We wrote a research paper that got an award at a top tier computer science conference. In fact, when Bill Gates came to the farm here and he wrote about FarmBeats, the title of the blog was, "Can the Wi-Fi in your phone help feed the world?" So we are bullish about it. I was giving this talk, and then one of the people in the audience was Professor Ratan Lal, who won the World Food Prize last year. And Professor Lal was like, hey, if you can start measuring that, I can use it to start measuring soil carbon using some of the surrogate properties. Now, that's one idea. It's still futuristic, but I think we need breakthroughs in science, in the startup community, in technology, to truly democratize measurement of carbon and other soil properties as well, so that we can then start really driving this carbon market so that you can accurately quantify the amount of carbon that's sequestered in soil. So that's one direction in which we need innovation. The other direction is, of course, in the policy side. I think we need to be thinking more about how we treat soil carbon, especially in farms. Even like there's discussions around permanence and all that, which is important to have, but we should also think of what's right for the planet, what's right for the soils, in addition to having all of those discussions around accurately measuring. Like, for example, if you use the right practices, you're going to be improving nitrogen use efficiency of the soil. You're going to be improving the soil organic content, the amount of organic matter, which is going to be important for the world. So when you talk of permanence, you also need to think of the benefits that it brings to all of us, to soils, to the growth of food, to looking at the entire ecosystem rather than looking at it very narrowly in the context of carbon and the permanence of carbon, and treating soil carbon in agriculture as the same as soil carbon for forestry. Now, some of these points are my own as opposed to what Microsoft's, but I think we need innovation in technology, in science, and also in the policy front for us to really drive the quick adoption of all of these markets.
Absolutely. Man, this has been great. So just a quick question on that. So you all have ground truth data as far as the moisture and EC measurement from the phone Wi-Fi?
Yeah, so we wrote a paper on this where we compared this to the way people do it like right now, compared it to off-the-shelf sensors. These were hundreds of dollars sensors, and compared that to a Wi-Fi based system. And we are performing as good for both soil moisture and soil EC.
That'd be incredible if they can also do that with carbon. Very cool. Well, I really enjoyed this, Ranveer. We'll have to maybe do a round two or maybe every 5 years as you write your memos. But no, I appreciate this and very exciting stuff. Thanks for taking the time.
Yeah, thank you, Tim. Really nice talking to you.
Well, thank you so very much once again to Ranveer Chandra for taking the time to be on the show. Some really fascinating ideas there about how Microsoft is thinking about bringing data to the farm. Very much appreciated, and I'll throw some links in the show notes about some of the work they're doing over there at Microsoft. Thank you as well to Barney Debnam, who provided the introduction to Ranveer to make this episode possible. I really appreciate your ongoing support, Barney. And for all of you, thanks so much for your time and your attention. I never take it for granted. I'll be back next week with another story of ag innovation.